Hey everyone, and welcome! Today, we're jumping into a couple of advanced topics from the BCBA task list, the kind of stuff that really levels up your clinical skills from good to, truly great. We're tackling D.8 on intervention analysis and G.19 on generative learning. These are the tools that help you build interventions that are not just effective, but elegant, efficient, and create change that actually lasts.
Okay, so let's get right into it with a question that I guarantee every single one of us has asked ourselves. Picture this. You've done your FBA, you've put a solid intervention in place, and hey, you're seeing progress. The data's going in the right direction. That's awesome, right? But the real question, the one that truly defines next-level clinical work, is this. Could it be better? Could it be faster, more powerful? Could it have a bigger impact on your client's life? That's exactly what we're going to unpack today. So here's our game plan for this session. First, we're going to shift our mindset, moving beyond just the basic ABCs. Then we'll open up what I like to call the intervention toolkit from D8, and we'll break down 3 really powerful types of analysis. After that, we dive into the magic of G19, how to actually spark learning that you didn't even directly teach. We'll look at the nuts and bolts of how to make that happen. And then we'll wrap it all up with a quick guide you can use for the exam and, honestly, in your very next session. Right, so let's talk about moving past the basics. It is one thing to prove that your intervention has a functional relation, that it works. That's the foundation, that's Behavior Analysis 101. But our real goal is to find the optimal intervention. For instance, a functional intervention might be a token economy that gets a student to stay on task. An optimal one might be a self-monitoring system that does the same thing, but also builds the student's independence. See the difference? We're aiming for optimal. And this is just so important. Our ethical code demands that we provide effective treatment. And effective doesn't just mean it kind of works. It means we have a duty to constantly be evaluating, tweaking, and refining what we do. We have to be scientists in our daily practice, always asking questions, always testing our assumptions, and always pushing to find the absolute best path for the people we serve.
And that leads us perfectly into task list item D8. This section is all about the why behind 3 very specific types of analyses. Now, don't think of these as some scary, complicated research designs. Instead, think of them as a specialized toolkit. Each tool is designed to answer a very specific question you'll run into when you're trying to perfect an intervention.
To make this super clear and hopefully really memorable for the exam, we're going to use an analogy. Let's pretend you're a chef, and your intervention plan is a recipe. You know the recipe is pretty good, but you want to make it absolutely perfect. Well, in your kitchen, you've got different methods, different tools to analyze and improve that recipe. Let's check out the first one.
First up in our toolkit is the comparative analysis. This is what you pull out when you're comparing 2 or more totally different interventions to see which one works better. You'll often see this done with an alternating treatments design, where you're quickly switching back and forth between the interventions. This lets you see pretty fast which one has a bigger, better effect on the behavior. Back in our chef's kitchen, the comparative analysis is like asking, which recipe is just fundamentally better? Are we making chocolate chip cookies or are we making oatmeal cookies? They're 2 totally different options, right? And we need to do a taste test to see which one's the winner. It's intervention A versus intervention B, simple as that. And check this out. This graph is a perfect real-world example. What you're seeing here is a comparison of 3 distinct teaching strategies for spelling words. You've got data for the no game condition, the game condition, and the game plus condition. Just by looking at the graph, you can visually compare how well the student did under each separate approach. That's a comparative analysis in action.
Okay, next tool, the component analysis. This is what you use when you have a big treatment package with lots of different parts, and you want to figure out which pieces are actually doing the heavy lifting. You can think of it like spring cleaning for your intervention. You're trying to get rid of any parts that aren't absolutely essential, making the whole thing more efficient. All right, back to the kitchen. For component analysis, we are not comparing 2 different recipes anymore. We've already decided our chocolate chip cookie recipe is the one. But it's a little complicated. It's got flour, sugar, chocolate chips, and walnuts. The question is, do we really need the walnuts? Do they make the cookie better, or are they just extra work? So we bake 1 batch with the walnuts and 1 without. We're testing if that single component is essential.
And our final tool in the kit is the parametric analysis. This is your go-to when you already know what works, but you're not sure about the dosage. You're taking one specific piece of your intervention and just tweaking the intensity to find that sweet spot. So you might be looking at, say, the length of a timeout, or the number of tokens needed for a reward, or how often you deliver praise.
In our kitchen, this means we know our chocolate chip cookie recipe is a hit, and we definitely know sugar is a key ingredient. But what's the perfect amount? A parametric analysis is like baking a batch with 1 cup of sugar, then another with 1¼ cups, and maybe a third with 1½ cups. We're not changing the ingredient itself, we're just changing the parameter, the amount, to get the best possible cookie. Okay, so let's boil this all down because this is the critical part for the exam and for your practice. You have to know which question each analysis answers. So a comparative analysis asks, which is better? Component analysis asks, is this part necessary? And parametric analysis asks, how much is best? If you can just lock in that core question for each one, you will always be able to pick the right tool for the job. All right, now that we've covered how to fine-tune our interventions, let's go even bigger. What if we could design our teaching so that our clients learn things we never explicitly taught them? That's the mind-blowing power of generative learning, and it's what task list item G.19 is all about. This is where we stop being just teachers and start becoming, really, architects of learning. I absolutely love this phrase. It just perfectly sums up generative learning. I mean, imagine you teach a client one skill, and from that single skill, they suddenly have 3 other related skills, without any more direct teaching from you. That isn't magic. It's the incredible result of smart, carefully designed instruction. It is, without a doubt, the most efficient and meaningful kind of learning we can possibly create. So, what exactly is generative performance? Well, to put it simply, it's when a learner can do something new, something novel without you having to teach it to them step by step. It's when they can take what you did teach them and apply it in a totally new way. The learning kind of takes on a life of its own. It's the difference between a student who can only solve the exact math problems you drilled and a student who can figure out new problems they've never even seen before. Okay, so this sounds amazing, right? But how? How do we actually do it? This isn't just about hoping for the best. There are specific, evidence-based things we can do to make this kind of emergent learning way more likely. And one of the most fundamental strategies is teaching concepts. The whole foundation of teaching a concept rests on 2 crucial processes. First, you have to teach stimulus generalization within a class. That just means the learner responds the same way to lots of different examples of the same concept. And second, you have to teach stimulus discrimination between classes. That means the learner figures out when not to respond, when something doesn't fit in that category. And this example just perfectly illustrates how it all works. To teach the concept of red, you need generalization. Your client needs to be able to say red when they see a bright red fire truck, a dark red apple, a slightly faded red crayon. They're all different, but they're all red. But that's only half the battle. They also need discrimination. They have to learn that a blue ball is not red and a yellow bus is not red. When you have both of those skills rock solid, that's when the true concept emerges. All right, let's pull all this information together now into a quick guide, something you can use to study from and to start applying this stuff immediately in your clinical work. We're going to synthesize the biggest takeaways for both D8 and G19. Okay, for the exam, this table is your best friend for D8. Just burn these core questions into your brain. For a comparative analysis, you're asking, which is better? Look for keywords in the question like compare or alternating treatments. For a component analysis, the question is this part needed? Watch for words like package or remove element. And for a parametric analysis, it's how much is best? And your keywords are going to be things like dosage, amount, or range of values. And for G19, these are your big picture goals. Remember, our job is to move way beyond rote memorization. We have to systematically, intentionally plan for generalization and discrimination from day one. The whole point is for our clients to use their skills flexibly out in the real world in new situations. Because true mastery, the kind of learning that really changes a person's life, is when your client can do something you never, ever explicitly taught them. So, I'll just leave you with this question to chew on. When you go back to your work, think about the clients on your caseload. Is there a treatment package you're using that you could analyze to make it more efficient? Are there 2 interventions you could compare to see which one is truly better? Or is there a skill where you could more systematically plan for those amazing generative outcomes? Which client's plan are you going to level up tomorrow? Thanks so much for joining this explainer.